It's K8BYP with a success, the HP8660B generator with the 86602B plug-in, 1.3 gigahertz. Its first RF test on the scope and the counter. Occasionally breaking a lock by a few hundred cycles, but probably hasn't been run in years. And this project has spanned well over a year to redesign and make a custom power supply, which is on the back of the unit. You can see my other 8660 videos where I start onto the power supply project but haven't quite gotten there, and there it's finished. Thanks to, I think it was Han Yan, pardon me if I mispronounce your name, at Meanwell for technical assistance in determining the supplies will work. This thing was a trick to do on a unit that I essentially knew nothing about, could not start up to test or measure the currents. I had to do everything by calculation. It wasn't exactly advanced math, but a little touchy. Just three Meanwell switching power supplies and one XP because I had to go to the XP to get the minus 40 volts. But the trick here, to see the sort of red colored toroids, a caution when recapping equipment. New capacitors have far less ESR. The 5.25 volt power supply in this unit has 71 tantalum capacitors spread across the unit. I calculated the total parallel resistance at 30 milliohms. So when that 50 watt supply starts up, it's going to try to dump 10 amp into all that. It's possible it's going to send overcurrent through one or more capacitors and maybe make them blow up. And tantalums don't vent, they explode all over the inside of the case. So I designed toroids to put in line with the supplies to dampen those turn-on transients. And they're made with 16 gauge wire, real heavy and difficult to wind. That keeps the series resistance down, so that doesn't affect the regulation of the power supply. Now the power supplies, the active power supplies, tuned in to half or better of the allowable error for the particular voltage. They're basically set at 0, 0, 0. 25 to 50 millivolts allowed. I think there's one that's 10 millivolts over. The rest are dead on. I very carefully checked for leakage current, both AC line and among the different supplies, because two of them are hooked up backwards. And the Meanwell engineer, I assume, said that that probably won't hurt it, and that was correct. So far it's working great, and I measured all those leakage currents, very small, tens of microamps. So here's a unit set on 20 megahertz, and we can move it around a little bit. 10 megahertz center, and we get dead on 10, 0, 0, 0, 0, 0, 0, 0 on this new 10-digit counter. This counter goes one more digit than a generator, and there's the sine wave with variable amplitude. I need to clean that control. That vernier is dirty, but front of the meter, I haven't verified amplitudes. I'm checking frequency with the counter, hoping I don't have to go in and do any alignment. But this is the 1 to 1300 megahertz plug-in. I have the other two. Someone kindly sent me the what is it, 100 megahertz, and then the one that goes to 2.5 gig. I still have to restore those. But every tantalum and every electrolytic capacitor in this unit has been replaced, and it was a nightmare. But the result is, it would be well over $10,000 to buy this unit new. Maybe twice that. Hikoi or Hakoi unit that went to, I don't remember, 50 megahertz, maybe 100, was like $10,000. So real RF generators are extremely expensive. This little AWG, which isn't necessarily a proper RF Jenny, was about 1,000. So very nice stable sine wave. And as I change the frequency of the generator by megahertz, we can see the response of this analog scope, how it drops. Get some graticule illumination here. But as it goes zooming up past 30 megahertz, see the amplitude drop. That's the roll off on the front end of this 60 megahertz scope. So at 60 megahertz, it still has a trace. 61 and change. The counter is coming off the channel 1 amplifier out the back of the scope. But as the frequency goes up, up, 70, 80, 90, 100, and I've turned the volts per division, that's 20 millivolts, so that's a 40 millivolt signal there. So at 100 megahertz, that scope's gone down to 40 millivolts from what it was, way over full deflection down around 10 megahertz. So that's where a unit like this is really useful for testing a scope like this, because the generator is infinite bandwidth compared to the scope. And this scope starts doing some significant roll-off at 20 megahertz. So realize the 60 megahertz rating for this is a 3 dB down. So 15 and 6 zeros, 15 and 19 hertz, and it's trying to flip in and out. So it needs some time to run and bake back in. This unit has a ovenized 10 megahertz oscillator, which I haven't checked. If that's off, everything else will be off. And this has a output for that, so I could drive it with this precision AWG for the reference in. And this unit also has a high dollar YIG master oscillator. Last YIG I looked up was $8,000. So this was probably a retired government unit, probably from the Oak Ridge site. So they sell this stuff off surplus. So for my purposes, this thing's working. Nice thing about this is that I didn't have anything to do receiver testing. And this will resolve down to a range of 0.03 microvolt, which is 140 dBm down. So that is necessary for testing receivers. And so far I've got nothing else here that can do that. So now this is working, I can go do the alignment on the HP8660 that needs to be done. So there it is, success.